Okay. Hi. My name is Arnold Jair Camacho Zamora. Um, Today, I will present you a problem with the vapor degreaser equipment. Um, what is a vapor degreaser? Steam degreasing equipment has the function of cleaning the metal parts of interest throughout the evaporation of a special degreasing substance for metal equipment. Um, This special substance will depend on the metal to be cleaned, since this must be compatible so that the grace dissolution occurs, condenses correctly, and without damaging the part. Um, the use of this degreaser is a great importance in the metal cleaning, electronics, aerospace, and medical industries, where the cleaning of their accessories is essential for the proper function of their equipment. What is the problem? I have a degreaser. It was a height of 5 meters, diameter of 2 meters, contained a TCA liquid with a depth of 20 centimeters. Mm, I need money and I want my equipment to work at 100%, but I work with a compound that is hazardous to health and pollutant. Where I am, there is an environmental regulation that only allows to emit the environmental 500 grams of TCE per day. Um, Sounds small, doesn't it? Um, well, how can I optimize my equipment so that it cleans as many parts as possible and in an efficient way, uh, without crossing the limit established by the regulation. Um, let's go with the thesis. The temperature at which the equipment works are highly related to the amount of TC pollution that is emitted to the environment, as well as to efficiency of the equipment. So the maximum temperature at which it can work without exceeding the local emission regulation must be calculated. Okay. Bueno, how do we do that? Where is the mass transfer formula for compound A with the condition that compound B remains static? And where it is recognized, as compound A, TCE, and compound B, air, as well as C represents the vapor phase concentration in the equipment. DAB is the diffusivity of TCE in air. L is height difference between the depth of the liquid substance and the height of the equipment. Finally, Y, A0, is the vapor fraction of TCE in the equipment. And to solve this problem, I will divide it into 4 steps. Step 1. Calculate the concentration of the steam. This variable is calculated with the formula of the ideal gas, and knowing that moles between the volume is equal to the concentration, we can make a series of simple clearings, and we obtain the equation on the left. The pressure we know that being an open system is 1 atmosphere, and ideal gas constant is shown in the slide, and the temperature is estimated and 305 Kelvin was chosen. Calculation of the TCE pressure, which is calculated with the Antony equation with data from NIST. And next, the mole fraction of TCE is calculated with the ideal gas equation. Step 3. The longest step, the diffusivity formula for TCE in air is follows the middle one. Practically, the most complicated part is the calculation of the molecule diameter and mostly the collision integral. And these are calculations that are much better explained in the Excel where they were calculated. Link that I leave at the bottom of the slide. Step 4. We already have all the variables to calculate the mass transfer of the TCE to the environment. We only have to substitute the values obtained. Be careful with the units. We multiply by its molecular weight and area in which we are working. Finally, the units that will give you are grams over seconds. We only convert the seconds to days to compare the amount that is emitted with the amount that is allowed. Results. With the first estimation, that was with a temperature of the 305 Kelvin or 31.85 degrees Celsius. We obtained the values shown in the slide, highlighting that the amount of TCE emitted is within the limit, so we can further optimize the equipment. Here is where the magic one Excel is used because with the solver tool, we save all the iterative attempts. Then with this tool, we calculate the final temperature, which is 40.2 degrees Celsius. In conclusion, thanks to the calculation of the maximum temperature, it was possible to reach an efficient optimization of the equipment. It was also discovered that equipment was the particularity that the higher the temperature at which it works, the higher the cleaning efficiency. However, working at high temperatures means a higher evaporation of the TCE compound and thus a higher contamination. And that is why it is important to have to the temperature measured and controlled and any type of distillation processes, such as a steam degreaser. My reference, that's all. Ya puedes pasar.